Welcome again. This is another problem that we have in front of us. So now we're going to go ahead and solve this one. As you can see, these are the things that we have for this problem, which is our E and I. So this is a measure to x. As you can see that I've already measured the x from the x-axis. So now we're going to go ahead and add this UDL, completing this 5 kilonewton UDL to the support, so that we're going to subtract it on the equation. Yeah? So yeah, let's start solving. This is our equation. Our equation, you're going to see our equation. So now we're going to start with our moments. We're defining our moments, sense of moments. So moments that are tending to turn this thing in anti-clockwise direction, they're going to be negative, as you can see, and the opposite is true. So let's begin by writing our moment equation, which is our 5 is going to the negative side, which is our distributed load, which is now we're going to subtract. It's going to be x minus a, which is our a is equal to 2. Okay, so that's our 2 meters squared. And then now we're going to go subtract the load that we just added, but now minus and minus becomes positive. Okay, so we're going to have 5 over 2 again into, remember that this is the load that we're including here, that we're talking about, that we are doing now. And the reason why you see this positive is because of this thing is negative. We are subtracting it, and then once you're subtracting it from remember that we are not given that that UTL that we just added underneath there. So now what's going to happen is once you subtract it, it's going to become positive because it's tending to go anti-clockwise, and then negative it's positive. Okay, so now we're going to say into x, our b becomes 4. Remember, this is our b, the way we just added it, so it's going to be 2 plus 2. We're going to that UTL we just added, which is 4. Okay, so that's it, that is our b. So we're going to subtract that b from the x, which is 4 squared. Okay, yeah, let's keep going. Okay, now we are talking about that 30 kilonewton is bringing this thing anti-clockwise also. Okay, so now going to be x, and then what is there before our x? It's 2, 4, 6. So now we cover 6, but now we're going to subtract that 6 from x, which is we're interested in that distance from that load to x. Okay, which is 6. Okay, so this is our equation. Okay, so now we are defining this thing. Okay, which must be equals to m. Okay, which is mx, guys. Mx, which is what is on top there. Mx is equals to what we just wrote. I'm going to say this is equation I. Okay, cool. Now we are looking for the slope. The slope is we are going to derive, or in fact we're going to remember that we're not deriving now, but to integrate. Okay, so we add 2 plus 1 there on top. Then when it comes to the bottom, it's going to be 2 times 3, which is the 3 that is going to be the power of this. So it is 6 altogether. So now it's 3 plus, okay, so 5 over 2 into x minus 4. Then again it's 3 there, guys. Okay, and then minus 30 divided by 2. Rather keep it by 2 rather than dividing and making it 15, so that we're going to see if we are wrong, so we can spot easily our mistakes. Okay, all right, this is equation 1. I call this equation 1. Okay, let's keep going. Now we're going over to deflection. This is a deflection. Deflection is going to be 24. 5 over 24. Remember, it's 6 times 4, so it becomes 24. Okay, then what is on the bracket remains the same, but the power changes to 4. All right, let's keep going. Also, yeah, it's 24. Okay, and then x minus 4 into 4. Okay, then now we're going to have 30 divided by 6. Okay, then x minus 6 into 3. That's it. Then ax plus b. Remember, now we have b now. This is another constant. Okay, so now these are the conditions. You know most of the conditions. The conditions, we're going to say when our x, we're going to start at 0, is equals to 0. Then now what is there? So when x is 0, then it means that our a is going to be 0. Okay, so we cannot use 0. So let's rather start at 8. When x is equals to 8, which is our L. Yeah, now we are going to find our a. Otherwise, if we're going to start with 0, we cannot find a. A is going to be 0, and b is going to be 0 as well. So now when x is equals to 8, which is covers the whole length. Yeah, so what's going to happen is that then it means that the deflection is 0 at that support when x is L. Yeah, so our deflection is going to be 0. I mean, our slope is 0.